So in this video, we'll consider what the redshift measurements can tell us. So using those, we can work out the speed that galaxies are moving away from us. And this is usually called recessional velocity or velocity of recession. And if we plot that against the distance that galaxies are away from us, then what Hubble discovered in the early 20th century was that there's a straight line of proportion between those two. Now, it's not a perfect straight line. You can see you've got a fair spread of points. In actual fact, we've got some galaxies moving towards us, so there's some kind of what we call local effects, where the gravitational forces from nearby galaxies are actually pulling some towards us. But other than that, we find almost all galaxies are moving away from us. And this was the kind of first stage in our understanding of the development of the universe. So, vast majority of galaxies are moving away from us, and that the recession velocity increases the further away they are. Now, if this was a standard explosion, they would all be moving away at the same speed. So it leads to the theory of the Big Bang, basically. In 1931, we got more data available, and then we've added to that since as well. And what we can show is consistently we get much more obvious straight lines from that data, that the speed of recession is proportional to the distance the galaxies are away from us. And we call the constant as proportional, then the Hubble constant. Now we'll discuss later the idea of that we can measure that Hubble constant just now, so that's really what that zero there indicates. But we'll talk later on about how that might have changed over time. Now, why does that suggest an expanding universe? Well, if you think about um, watching a universe expand, so this is a two-dimensional picture of a universe, and what we're going to do is the galaxy zero, for instance, where we're taking our measurements from. And we've got three other galaxies in at 10, 20, and 30 units of distance away. I'm not going to get hung up on the units of distance. There's a wee bit, of course, about light years and megaparsecs or parsecs, but you don't need to know much more about them. If we look at our universe expanding, then if the whole universe is expanding rather than just an explosion from a single point, then what we find is that after a certain unit of time, Galaxy 1, which started 10 away, is now 40 away, and 80 and 120 for the other two galaxies. So their change in distance is 30, 60, and 90. But a change in distance in a unit of time is a speed. So this idea of the expanding universe models the data that we're finding, right? That the speed is proportional to the distance they are away from us. So if Galaxy 2 starts twice as far away from us, then its speed is going to be twice as fast when we measure it just now. So if you plot that graph of velocity versus distance, you get a nice straight line, and we can compare that with our measured data. This doesn't imply that G naught is the centre of the universe. If we picked any galaxy and measured the distance to the others, we would get a similar table. It's the fact that the whole universe, space itself, is expanding that provides this model, provides this data. So Hubble's law implies that the universe is expanding. It's probably the most important data that we have as evidence of the expanding universe. But we'll discuss other sources of that as well.